Hello, welcome to next session of 10th of material. In this session, we will solve some subjective questions of engineering services examination uh, based on complex tests and introduction chapter. Okay, so the first question is at a point in a loaded structure in pure stress state of tau is equal to plus minus 40 MPa prevails on two given planes at right angle. What would be the state of stress across the planes of an element taken at 45 degrees to the given planes? Second part. What are the magnitude of these stresses? So, as the uh, only shear stress is given, that is equal to plus minus 40 MPa, so it is the case of pure shear. Okay, so when we draw its value, that is the that is the plane of this tau, and draw its whole circle, then it is clockwise. This is anti-clockwise, so it will be like this. It will be minus 40 mpm tau stress. Similarly, this will be clockwise. This is clockwise shear stress. So the more circle will be symmetrical about this origin. So the maximum normal stress is this sigma 1 on x-axis and minimum shear stress, minimum normal value is minus 40 rpm. So principal stresses are at 45 degree to the plane of maximum shear stress, and these are also equal in magnitude, but magnitude to the tau, because they are also the radius of the circle. So sigma 1 is 40 rpm, sigma 2 is minus 40 rpm. So at 45 degree, principal stretches will occur with magnitude plus 40 MP and minus 40 MP. Okay, so we have answered both the questions. Next question is the Mohr circle for a plane stress is a circle of radius r with its origin at plus 2r on sigma axis. Sketch the Mohr circle and determine sigma max, sigma minimum, sigma average, tau xy max for this equation. So this is the Mohr circle of radius r, and it is at a distance 2r from origin. Okay, so this is r, this is 2r because this is radius, and this is the distance given. So this is 3r. Okay, so sigma max is 3r, the sigma minimum is this is only r, this is sigma minimum, that is r. Okay, this is 3r, this is r. Okay, so sigma max is 3r, sigma minimum is 2r, only r, and sigma average is this 2r, and tau xy maximum is r. Okay, next question is the state of stress at a point in a loaded machine member is given by principal stresses. Sigma 1 600 MPa, sigma 2 0, sigma 3 minus 600 MPa. What is the magnitude of maximum shear stress? First part. Okay. Second part is what is the inclination of the plane on which the maximum shear stress acts with respect to the plane of maximum principal stress sigma. Okay. So maximum principal stress is 600 MPa and minimum principal stress is minus 600 MPa. So maximum shear stress is sigma max minus sigma min by 2. Okay, that is 600 plus 600 by 2, that is equal to 600 MPa. So tau xy is 600 MPa. So shear stress always act at a plane 45 degree to the plane of maximum shear, sorry, maximum principal stress. Next question is the data obtained from rectangular strain gauge rosette attached to stressed steel member are epsilon naught minus 220 into 10 to the minus 6, epsilon 45 120 into 10 to the minus 6, and epsilon 90 220 into 10 to the power minus 6. Given that the value of E is equal to 210 to the power 5 Newton per mm square and Poisson's ratio is mu point 3. Calculate the value of principal stresses acting at the point and their direction. Okay, so this is epsilon x. Okay, take epsilon 0 as epsilon x, then epsilon y will be epsilon 90. This is epsilon 5. Okay, and also it is given that the epsilon 45. Epsilon 45 is 120 into 10 power minus 6. Okay, these three strains are given. Okay, and 45 degrees. Okay, okay. These three strains are given. So by using the formula, of normal strain, we can have epsilon x by epsilon y by 2 plus epsilon x minus epsilon y by 2 cos to theta tau xy sin to theta by 2. Okay, putting the value of epsilon theta or epsilon theta is equal to 45 and epsilon x and epsilon y value minus 220 and 220. Okay, and then put in the value of epsilon 45. So then we can have tau, oh sorry, gamma xy, that is shear strain acting at this stage. Okay, we can find out. Okay, so after finding out, we can use the formula for principal strain, that is epsilon x plus epsilon y by 2 plus minus sigma x minus sigma y square plus tau xy square by 2. Okay, and we can write the answer. Okay, these are the principal strains. We use the formula, these are the formula based questions. Okay. Next question is, if allowable stress for the material in simple tension or compression is 100 Newton per mm square, calculate the factor of safety with each of the following criteria for failure for the following conditions. Sigma 1 is equal to 60 Newton per mm square. Sigma 2 is equal to minus 30 Newton per mm square. Assume mu is equal to 0.25. According to first maximum stress criteria, 2 maximum shear stress criteria, 3 maximum strain criteria, 4 maximum distortion energy criteria. So the principal stresses are sigma 1 and sigma 2, that is 60 and minus 30. And allowable stress is 100 MPa. So in first case, uh, that is of maximum stress criteria, the allowable stress, uh, sorry, the allowable stress is 100 and maximum stress is 60. So factor of safety is according to maximum stress criteria, allowable stress divided by principal stress, that is 1.667. Next, in second case, that is maximum shear stress criteria. When the allowable stress is 100, okay, then the maximum shear stress is 100 by 2. If you divide it by factor safety, then it is the working stress. Okay, Then working shear stress. So, and shear stress according to Tresca criteria or maximum shear stress theory is sigma 1 minus sigma 2 by 2, that is 60 plus 30 by 2 or 45. Okay, so factor of safety is 50 by 45. Okay, next maximum strain criteria. Maximum strain will be sigma into E. If it divided by factor of safety, then it will be working strain. Then 60 plus 0.25 to 30 divided by E. Okay, E will get the equation will be 1.4. Okay. Next, maximum distortion energy theory. Now, to calculate the distortion energy theory, so distortion energy in failure, we have to, sorry, for level stress, we have to divide sigma by FOS and then find out the distortion energy. Then it will be sigma FOS squared by 12G. Okay, or this is the formula for the shear strain energy. We put sigma 1 is equal to sigma by FOS, we can get this. Okay, so this is the maximum storage energy stored in working specimen. This is the allowable distortion energy. Okay, so from this we can calculate sigma and then we can calculate FOS, which is 1700 by 78.37. This is 1.252999. Next question is our first chapter, introduction chapter. If a load of 60 kilonewton is applied to a rigid bar suspended by three wires attached in the above figure, what force will be resisted by each wire? The outside wire are of AL aluminum, cross-section area 300 mm square and length 4 meter. The central wire is steel with area 200 mm square and length 8 meter. This is the figure. Initially, there is no flag in wire, flag in wires. E is equal to 2 into 10 to the power 5 Newton per meter for steel and 0.667 into 10 to the power 5 Newton per meter for aluminum. So this is steel wire. These are the aluminum wire. Okay. So the load will be shared by these aluminum wires and steel wires. So if the PL is a load shared by the aluminum wires both, okay, half will be there. Okay. uh, for each wire, for each aluminum wire, for it will be PL by 2. For it PL by 2. Total is PL. Okay. The total load is PL plus PS is equal to 6 kilonewton. Now understand the in three bars will be same. Okay. So changing length of aluminum divided by changing length of steel will be same. So PA changing length is PAL by AL into LAL by EL and PS by AS, L by AS. Okay. For as we are taking two wires combined for aluminum, for the area will be 2 to 300. For the steel it will be 200 and length will be 4 meters for aluminum. LS for steel will be 8 meters. This is here. PAL is PAL is given and ES is also given. Okay. So we can put directly the values. Okay. Okay. We can put the values directly. Okay. And then we can find out the ratio between PAL and PS. And after that, we can find out by using PL plus PS is equal to 60. We can find out PS and then we can find PL. And the load taken by each aluminum wire will be half of PL, that is 20 Newton. So the load taken by each wire is 20 kilo Newton. Next, considering principal stresses in steam boiler drum as P 0.5 P 0 and Poisson's ratio mu is equal to 0.3. The equivalent stress in simple tension as sigma. Find P in terms of sigma due to maximum shear stress theory, strain energy theory, distortion energy theory. Now the maximum transfer that is sigma 1 and minimum transfer is sigma 2. Sigma 1 is equal to P and sigma 2 is equal to 0.5 P. So the maximum shear stress is tau is equal to sigma 1 minus sigma 2 over 2. Okay, so first we have to find out the according to maximum shear stress. So the maximum shear stress in this case will be 0.5 by 2 into P, that is 0.25 P. Okay, and and the equivalent stress in simple tension is sigma. So the maximum shear stress is sigma by 2. So this tau will be equal to sigma by 2. So P is equal to, sorry, so sigma is equal to 0.5 P. Okay. Now the second theory is strain energy theory. According to strain energy theory, the strain energy stored in the material is this sigma 1 square plus sigma 2 square plus 1 square minus 2 mu sigma 1 sigma 2 sigma 3 sigma 1 divided by 2 e. Okay. Sigma 1 is P, sigma 2 is 0.5 P and sigma 3 is 0. So these values we can find out that is 0.475 P square by E. Now when only sigma stress is acting, the strain energy is sigma square by 2E. Equate these two and find out P and find out P. Okay. Similarly, according to distortion energy theory, you can also find out. Okay. Next, at a point in a loaded component, the state of stress is given by sigma x is equal to 270 MPa, sigma y is equal to 130 MPa, tau xy is equal to plus minus 40 MPa. Determine maximum and minimum stresses. Okay. And planes of and which they act the maximum the maximum shearing stress in magnitude and direction. So these are the formula based questions. So the formula for sigma 1 is sigma x plus sigma by 2 plus minus 1 by 2 sigma x minus sigma y square plus 4 tau x y square. You can put sigma x equal to 70, sigma y equal to 30, and sigma tau x y is equal to 40. So we can find out sigma 1 and sigma 2. And by this we can find out after this, we can find out the direction of the principal setting. These are the direction of principal setting. That is variable power by sigma x minus sigma y. Okay. So then we can find out principal train. These are the principal train. And other are, and then we can find out the maximum shear stress. This is we have found out sigma 1 and sigma 2, sigma 2, sigma 1 minus sigma 2 by 2 is maximum shear stress. So this is also the so maximum shear stress there is uh, Principal plus 45 degrees. So both the recipe become 45 and equal to maximum principal stress, maximum shear stress rate. Next, this is a question of uh, thermal safety. Okay. A steel tube 2.5 centimeter external diameter and 1.8 centimeter internal diameter encloses a copper rod 1.6 centimeter diameter to which it is rigidly joined at each end. If at a temperature of 20 degrees there is no longitudinal stress, calculate the stresses in the rod and tube when temperature is raised by 210 degrees Celsius. Given E.S is equal to 210 GPa and alpha S is equal to 12 into 10 to the minus 6 per degree Celsius. EC is equal to 100 GPa and alpha C is equal to 20 into 10 to the minus 6 per degree Celsius. Okay, as both the bars are fixed, okay, or rigidly held, so there will be equal extension like our article that we have solved in uh, theory portion. Okay, So this is the steel bar, this is the copper bar. As alpha for copper is more, so alpha will try to extend more as compared uh, to steel. So, but this expansion is restricted by this force P, and this expansion is enlarged by this force P. Okay, so change in length of copper should be equal to change in length of steel. Okay, so now the copper is subjected to thermal stress and compressive stress, and sorry, the copper will be the extension of the copper will be due to uh, the extension of the copper bar will be due to free expansion of copper and compression of this copper compression of this force P, and the expansion of steel will be due to free expansion of steel and expansion of this expansion due to this P. Okay, so the expansion will be same in copper and steel upon temperature increase. So del L C is equal to del L S. So this alpha delta L will be due to thermal stress, and this minus PL by AC will be due to this P. Okay, so this alpha S delta L will be due to plus, and this will be due to this. Okay, so equating these two, we can find out P that we have found in theory article. Okay, so that we said. So after finding out P, we can divide it by area of steel tube, and then we can find out stress in the steel tube. Area of steel tube is pi by 4, 2.5 square minus 1.8 100 square. Okay, so these are the calculation we can make. Okay, and copper stress in copper rod is P by AC. So P is same for both, and area is 1.6 square 100. Sorry, 100 square into pi by 4. Mhm. 1.2. Okay, next question. The state of stress at a point in a structural component of elastic material are given as follows. A normal tensile stress of 160 MPa and shearing stress of 120 MPa on one plane. A normal compressive stress of 110 MPa and complementary shear stress of 120 MPa on a second plane. Okay, orthogonal to first plane. No stress on the third plane, which is orthogonal to above two planes. Determine the principal stresses and direction of the principal stresses on each of, on which they act, position of the planes on which there is no normal stress. So sigma x is given as 160 MPa. Okay, this is 160 MPa. Shearing stress is 120 MPa. Another is um, and normal compressive stress of 110 MPa. This is 110 MPa, 10 MPa. This is 120 MPa. So this is using direct formula. You can calculate sigma 1 and sigma 2. Okay, so this is the formula that we have used so many times, and this is the formula for the planes of the or principles of the order principle planes. Okay, and to find out second, uh, position of the plane on which there is no normal stress. To find out the planes at which there is no normal stress, we put the sigma theta is equal to 0 is the formula of sigma theta. Okay, putting sigma theta is equal to 0 and putting the value of sigma x and sigma y, you can find out theta. Okay. So this is the by this will be solved by item 10. Okay, so it is better to use more than or we can solve it by next question. A tapering bar having D1 and D2 as diameter of end sections and another bar of uniform cross section D are of same length. Both are subjected to same axial pull P. What should be the value of D in terms of D1 and D2 so that both bars of same material will have same attention. Evaluate maximum stresses in both the bars. Okay, this is the taper bar. Okay, D1 and D2 are major and minor diameter. Okay, so you know the attention of taper bar is 4 PL 5 D, and if the bar is of circular section throughout same diameter, okay, then its extension is 4 PL divided by pi d square. If we equate the two, you can find out D is equal to D1, D2. Okay, then the maximum stress in the taper bar will be at minimum diameter. Okay, so it will be at here. Okay, maximum stress and minimum stress and circular bar it will be uniform throughout. Okay. That's all.